Amazing. All right, I'm going to whiz through these because I've been told that we are short on time. So just a quick overview of blue carbon in Australia's greenhouse gas inventory. So how we determine what activities we capture, we're pretty much guided by IPCC guidelines and also guidelines and decisions by the UNFCCC Conference of Parties. Another thing that determines what activities we can capture is availability of activity data, which is a big one. Give you a quick background, Australia has been reporting coastal wetlands in our greenhouse gas inventory using the IPCC 2013 wetland supplement since 2017. We've taken a stepwise approach implementing guidance from IPCC in our inventory, and we continue to refine as data becomes available. We're always, as with other aspects of our inventory, subject to continuous improvement and verification. The inventory emissions estimates are also subject to annual independent UN technical review in compliance with UNFCCC requirements. So what activities do we capture? If we can go to the next slide. Perfect. That means you can hear me, which is good. So activities captured. So we capture establishment and removal of mangroves and tidal marsh, and we capture removal of seagrass habitat due to capital dredging projects. And if we can go to the next slide, I'll just give you a quick overview of, so with the mangroves and tidal marsh, this is a tier 3 model. So we model this using the department's full carbon accounting model, which is a spatially explicit modeling system, and it is completely informed by satellite imagery to pick up the changes in land use. Mangrove model is calibrated in full cam to mangrove ecosystems around Australia's coastal land area. Mangrove forests, as I'm sure you probably are aware, meet the definition of forest land. So we're reporting emissions and removals under land use change and forestry sector, removals of mangroves coming from forest land conversions into settlements or wetlands, and then establishment of mangroves is reported under land being converted to forest land. And with the next one, I'll quickly run through the seagrass model. So this is a tier 2 model. Emissions from seagrass arising from excavation of seagrass habitat. So we're really just picking up where there are capital dredging projects for port construction or expansion or other commercial or industrial development activities. So that's the activity data essentially. A survey was, so we set this up in 2017, and a survey was commissioned to provide information on all the capital dredging activities that had occurred between 1990 and 2016, and then everything after 2016 we're identifying through Australian notices to mariners and state development approvals to estimate any, to pick up any capital dredging activities and estimate an area size, and then we model the area of seagrass removed from those projects. And then, these are reported under land use change and forestry sector, under wetland remaining wetland, because there's no actual change in land use there. It's quite a small part of our inventory. And then just quickly with improvements moving into the future, so we continue to refine our approach as data becomes available. We're always looking to improve our methods where we can. Always subject to continuous improvement and verification. We have some changes coming up in the next inventory report for 2025, which will be out April 2025. So we're expanding the UNFCCC reporting categories for mangroves. So we currently report them all under forest conversions to settlements. But what we're actually seeing in the land use data is that quite a lot of the transitions are actually forests into wetlands rather than into settlements. So we're going to just update the categories there. And we've also got another big change with our full cam model, moving from Landsat to Sentinel satellite imagery, which is going to give us a higher resolution, which should improve the accuracy of our data. And that was, I hope, quick enough for you.
Wonderfully succinct. Thank you, Victoria, and beautifully presented. So maybe we'll do me next. And what we're going to do, Victoria, in case you didn't catch it, we're going to have a little bit of a panel discussion after all these presentations, so we'll bring everybody together then. Right, the US inventory. So I'm just going to whiz through this. We've also been including coastal wetlands within the greenhouse gas inventory. It's been a process involving many agencies. NOAA take the lead on bringing together the science to be included, and we provide that information to help the EPA in that process. But we really draw from a lot of universities and try and synthesize all of this information together. A lot of science. We're interested in vegetated coastal wetlands, remaining vegetated coastal wetlands, and then all of these subcategories here, and then lands converted to vegetated coastal wetlands. Mangroves do fall under both coastal wetlands and under forestry, depending upon stature. And that caused a little bit of bit of work between us and Forestry Service on who gets which mangroves. Interestingly, the bigger mangroves are in Florida, the small mangroves are in Texas, so they fall under coastal wetlands. Not everything is bigger in Texas. Emissions of interest. Intact wetlands, methane, CO2, impacts of drainage, excavation activities, not really that much going on anymore. Conversion to open water, where we see that as a human impact because of redirection of sediment supply causing erosion. Conversion, forest activities, they fall under forest lands. Methane emissions from impounded waters included this year, thanks to the work by Kath in bringing that into the 2019 refinements. And then nitrous oxide emissions from aquaculture. We use a NOAA data set to give us the activity data. We deploy the emissions factors. And this is our process. Our first big decision was to use a managed land proxy, which different to Australia, which has been used in activity-based. We look at the entire landscape and account for it that way. We define coastal lands as everything that's below tides to the extent of vegetated intertidal coastal wetlands. We don't yet include seagrasses in our inventory, though interestingly, the subnational level, some of the states are including seagrasses within their inventories. The activity data is from the NOAA CCAP process. We quantify our land use change from 1990 to 2022 based upon activity data that comes out at intervals from the CCAP data set, and we ascribe CO2 and methane emissions associated with that. Nitrous oxide is associated with aquaculture. Now, we use the Tier 1 default value from the IPBC wetland supplement, but for the US, it's a super small number and not really of consideration. Other countries with a lot of shrimp ponds, Daniel, then this might be a bigger number to include within the inventory. And then we look at calculating annual emissions and removals from vegetated coastal wetlands remaining, vegetated coastal wetlands converted to unvegetated open water, unvegetated open water converted to vegetated coastal wetlands, which might be a form of restoration, and then lands converted to coastal wetlands, which would be a form of restoration. I'll skip through this part and this part and this part. What's our main sources of error? Our main sources of error of calculating methane emissions across the salinity gradient. And that's something actually we're going to be working on improving this year. We have actually some great data sets now coming out of NASA and also coming out of NOAA on, to help with both the mapping of wetlands and also calculating methane emissions across estuaries. Our other biggest source of error is what happens when wetlands erode, particularly Mississippi Delta. And we still use a Tier 1 value for the depth of wetlands impacted by that. And so that's something we're also looking to work on. And I guess that's it. Recent planned improvements are the list there, but really working on the methane emissions and the soil erosion. So we've been making progress. Each year we improve it. My main message, I think, would be that there's the default values and approaches that can be used. There's a lot of remote sensing data, so countries can and should have the opportunity to, for their own national circumstance, look at bringing coastal wetlands and mangroves into their greenhouse gas inventory. And And if anybody would like any help, we'd be very happy to have discussions as we go forward. Thank you very much. I'll leave it there.
Will you sit there?
Oh, me too. You can bring Frida up.
Yes. Let me call Frida up here to present the case of Indonesia. So 3 things that we are expecting to share across the table here with regard to the emission factor, activity data, and the most recent inventory. Frida.
Okay, thank you. So actually, I've been asked to present the greenhouse gas inventory. So I discussed with my colleague from the Ministry of Environment and Forestry, and also Pak Tony from the National Development Agency to discuss about what we can share to this dialogue. So I just have like a very, quick look about the Indonesia greenhouse gas inventory. So like this is the overview that we have here. So how we report it. So we start from the private sector, and then from the private sector or any entities, we report it to the regional or provincial government. And then from there, we have like the key ministry who are responsible for the reporting. And then at the end, this is the report. One of the report last year is like led by the Ministry of Environment and Forestry. And this information also used for not only for the reporting for the NDC, but also for the national low carbon development. And this is like the key ministry who are responsible to report the greenhouse gas inventory. And then, so we skip to the where mangrove is reported for this emission. And here we can see that how we have science to support the forest and land use sector. Mangrove is the overview of our greenhouse gas inventory for the 5 main sectors. So how we report mangrove in this greenhouse inventory? So mangrove is included in the forest. So here we can see that mangrove is divided into 2 main components. The first one is the primary mangrove forest, and then we also have mangrove, the secondary mangrove forest. So we don't have mangrove as the wetlands. So the wetland is not estimated in our greenhouse gas inventory. And here we go. What we have for mangrove is included as a forest land. So mangrove is reported, the emission from mangrove or removal is reported under the forest land, remaining forest land. So we have good news in the last 3 years. So we, instead of like we emitted, so we sort of like remove it. So this is how we have for mangrove included in the forest land. So unfortunately, we don't have mangrove like as a different report for this one. And what's next? We have many challenges for mangrove and seagrass as a blue carbon. So we don't have blue carbon explicitly in our report, but we do have mangrove, and in the future we try to have seagrass as well in our NDC as the mitigation action. So for mangrove, we have a lot of job to do if we want to take the mangrove from the forest. So it's been like, probably we can learn from US how if we want to take the mangrove into like the wetland. And for mangrove, for the methodology as well, now we are developing the methodology, but Daniel now is like proposing the methodology that we can be standardized and we use as the national protocol for the mangrove blue carbon counting. And for seagrass, as in our NDC, we acknowledge ocean, but not blue carbon. So we're thinking of like a seagrass to be included as the ocean sector, in ocean sector. So now we're trying to build up the baseline. So we have many support from international or also from the NGO to build the baseline because we still have insufficient historical data inventory. And the good news as well, lately we just released the ministerial decree about the next Indonesian NDC and also the roadmap for the climate change mitigation in ocean and fishery sectors. So blue carbon can be part of this sector. And from here, now we have a lot of program and project in mangrove map, in seagrass mapping. And also how we sort of like updating the data and research study about the activity data and also emission factors, and proposing the mitigation action in the ocean sector. So the last slide, I would like to share one of the example how the international support to our blue carbon project. This is one of the project supported by the AFD, the French government. So here we want to have, at the end, we have 3 sites as the pilot sites. And from here, we want to get we want to build the blue carbon map and get some recommendation if the seagrass and blue carbon will be in the NDC for the mitigation, not only for adaptation. And we trying sort of like integrating all the blue carbon related policy. And also we try to have the blue carbon MR3 as the process for the blue carbon finance mechanism. So I think that's all my presentation. Thank you.
Thank you, Frida. So let's hear the last example from Japan. Shohei, are you ready?
Thank you. I will proceed my presentation. This is the same slide. In spite of our efforts, local efforts, the size of area of blue carbon ecosystem, especially seagrass and seaweed, are decreasing nationwide due to environmental change. And expansion of seagrass eaters such as fish or sea urchins. It became about 160 kilohectare in 2022, which is half of 1990 level. To stop this decreasing trend and to save multiple benefits which we enjoyed, government of Japan have a wide range of support to local people. We think GHG inventory is one of the support. That is because GHG inventory provides scientific basis to local people and give confidence to local people that their activities are a part of world global efforts to tackle climate change. This is our full time series of GHG inventory. Blue carbon is under the line in the green one from 1990 to 2022. Okay, skip. In my understanding, Japan is the first country which report the seaweed into our inventory. Many countries did it in mangrove or seagrass because IPCC guidelines are completed. However, in terms of seaweed, we have to create new methodology to calculate our carbon sequestration. The amount is 350 kilotons annually. That amount is relatively small than Japan's total emission, which could be 1 billion tons carbon dioxide. However, the amount is still significant because it consists of about 140,000 typical households of Japan who emit the carbon dioxide. Based on, okay. This is methodology. Recent knowledge, academic knowledge shows that there are 4 different processes that seagrass and seaweed fixed carbon. One process is in the on-site sequestration in the sediment, which is led by a root system of seagrass. However, in the seaweed, we have another 3 routes to sequestrate carbon dioxide. That is transport to the sediment or deep sea or stored in the water as a RDOC, refractory dissolved organic carbon. Based on this concept, Japanese scientists, in collaboration with government, developed a model and parameters to calculate carbon sequestration. This is the equation. You can see basically this final line. The carbon sequestration is represented by area multiplied by fixed carbon dioxide per area. And IJK is, I is area, J is ecosystem type, K is sequestration process from 1 to 4, which I mentioned in the previous slides. Different scientist teams led by Ministry of Land, Infrastructure, Transport and Tourism estimates the area, and another scientist team led by Ministry of Agriculture, Forestry and Fisheries derives 3 factors to get fixed carbon dioxide per area. There are examples of academic papers we used. They set parameters that represent quantity of carbon fixed in each 4 processes by 16 types of coastal ecosystem in 9 sea regions. In setting parameters, they take into account the ecology of the species. For example, seagrass that stick to rocks, not sediment, or seaweed which has no root system are not counted for on-site sequestration. Finally, this is our result as time series. In 2022, about 350,000 tons per year were fixed as blue carbon. In average, 6 tons of carbon are sequestrated annually by 1 hectare of seagrass. And 1 ton of carbon dioxide was fixed by 1 hectare of seaweed. Detailed data research paper on the calculation is indicated in our national GHG inventory document of Japan, which is available in UNFCCC website. Thank you very much.
Hey, so I think we will have less than 30 minutes for open discussion about this inventory. And I can summarize more or less with regard to the emission factors and activity data. It's quite very kind of approach used in these 4 countries. In Australia, Tier 2 is used, and it is related to wetland, remaining wetland, and very high resolution of Sentinel satellite is used. In the US, I'm surprised that you still use default values Tier 1 for wetland, and I hope there will be new numbers used in the next round of inventory, and certainly seagrass will be included. In Indonesia, it is not part of wetland yet, but it was reported as a FOLU sector, or even CHOP from agriculture is only FOLU sector, but differentiated between secondary and primary mangrove. Wetland is not included, seagrass is not included, but will be there very soon. In Japan, newcomer, seagrass and seaweed will be playing its role in terms of inventory with specific numbers in terms of emission factor to be included. But across the table, I can see here that the commonalities that has to be met is the IPCC or UNFCCC principle in terms of TAC principle, the transparency, what is the other 3? Completeness, comparability, which has to be met. So there are a number of reporting that is going on at the moment, in addition to national communication, NDC, and also biennial updated report. They have to be consistent, the 3rd C. Any questions, clarity, and comments from the floor? You almost raised your hand. Yes, you are.
Thank you.
Please address to whom your question.
So hey, I'm really impressed with the time series on seagrass and seaweed that you've shown for Japan. I have to admit I've never seen such time series. I'm interested, what sensors did you use for that from the 90s? So with Landsat you were able to identify? Thank you.
Okay, thank you. Our time series basically on the, from the on-site survey and satellite observation. We have data of on-site survey in 1990 and 1999, only 2 data. And we have model to calculate the recent term which observation is available. But observation includes satellite and other drone data or something. And we combined every data. So on-site to on-site data and modeling data for 2018 to 2021. So only 4 data and 2 data. And extrapolate and interpolate all the data and derived time series. So I cannot say the precise name of the satellites, but we combined any available data in one place. Thank you.
Okay, so it's more or less like subnational level kind of assessment. Victoria, are you still there? Just in case people ask about Australia. More questions, comments? Tony.
Thank you, Pak Daniel. This is more of a comment. Thank you to all our presenters. So thank you, Frida, for mentioning the last slide. This is the project that we are doing currently. As you can see, we still have a lot to do in terms of the blue carbon submission into the NDC. Daniel, you mentioned about the mangrove, the advancement into the calculation of the volume and all the stuff for the inventory, but definitely for the seagrass, we have a lot of work to do. But just want to let everybody know that in Indonesia currently in this interagency, interministerial work, we are developing the national action plan for blue carbon, actually currently led by Frida at the moment. A little bit of information. About less than 2 weeks from now, we are going to have a new government, new president. So we hope that this is going to be a good opportunity for us to bring blue carbon into the attention of the new government. Because, for Indonesia, blue carbon is so important. And definitely support from you guys will be appreciated. Thank you.
Thank you, Tony, for additional information. And perhaps the national focal point will also be moved somewhere else, right? Okay, any other questions, comment? Kath?
Well, I don't know whether Victoria's there, but I can also show him what this thing. So I'm sort of interested in the interaction between the inventory and the commitments to the conventional biological diversity. So which often is the economic, takes the form of the environmental economic accounts. I mean, that's what Australia is doing. And I wanted to know about the whether the intention is to use the same data, like how are these two things intersecting or are they not? So I guess that's a question for everybody who does inventory, how much they're sort of paying attention to these other commitments to other conventions.
Victoria, still there?
I am still here.
Yeah, go ahead.
So in terms of Australia, we have just lodged, because I know that the ABS are the ones that are putting together those environmental economic accounts on our side. And yes, we do include the mangroves in those carbon stocks, and we also do include the seagrass meadows in the carbon stocks as well. So we have a stock and we have a stock change, I believe. Does that answer your question?
Thank you. Any other comments? Japan?
Japan also use biodiversity data into GHG inventory. As I mentioned last question, 2 on-site data is from biodiversity section. However, to combine the data with other types of data, we need to modify something. So we cannot use the same data into inventory. Thank you.
Yeah, and
Steve?
I guess from the US point of view, we use the same data sets, but for different purposes. So there's no direct link between the inventory and biodiversity metrics, but a lot of it is measured by land cover change. What we do in the US greenhouse gas inventory is we take a managed land proxy approach, and sometimes we're asked, like, why would you do that when you can do it by activity based? And really, we don't have the data to do because there's been thousands of restoration projects in the US, some better than others, some healthier than others. And we've got no real data sets that are comprehensive that help us really understand what's going on. But by mapping land cover data, which we have a lot of, we can track. If a pixel turns on, we track it. We do actually have tier 2 emissions factors. I just skimmed across that a bit, maybe too quickly. And so it allows it, and what's really interesting about that is it allows, if you use a managed land proxy and you're measuring everything, you can really start to tease out or be aware of the broader policies beyond projects. Because the US tends to take a policy-based approach. They gave $420 million to eastern states to just work on coastal restoration. It's a policy approach to get something done. And I think, and also, it also helps us reflect that, the US has actually done a surprisingly good job at protecting its coastal wetlands. Only 12% of all the coastal wetlands have been destroyed in the last 150 years. Now, some estuaries, like San Francisco Bay, that was 95% in one estuary. But across the entire nation, it's only 12%. And it helps reinforce some of the policy discussions to some degree that the reason we have these coastal wetlands is because we put those policies in place. And we would see in our inventories coming up if we relax those policies, leading to a loss of future emissions.
Frida?
I think like Indonesia is also the same, like we use the land use change for the inventories, especially for mangrove. And then we also acknowledge the biodiversity, but I'm not sure about the data we use the same or not for the inventory, but we do really acknowledge the biodiversity. Yeah.
Thank you. It also depends on how the national focal point of this convention talk with each other, right? In my old days, I was the national focal point of both UNFCCC and CBD, and it was quite convenient, but the issue was not that, important yet. In the next UNCCD in Saudi, they are trying to approach UNFCCC as well to find commonalities in terms of inventory. So this is interesting development. We still have 5 more minutes to go. 2, 3 more questions.
I'm not a scientist, so this might be a really silly question for Steve, but why does methane have the greatest rate of error?
Because methane depends upon salinity in coastal systems. When you have salinity is greater than half that of seawater, methane emissions are very low, and then it ramps up non-linearly as salinity decreases. That science is well established. How do you map that across the salinity gradient is really tricky. Right now we only have 2 classes, saline and non-saline, within our mapping. We actually have a new layer which has come on this year, which gives us saline brackish and fresh. And so we're going to have a much tighter relationship, I think. But it really reflects that you're trying to calculate a methane emission based upon salinity, and we don't have good annualized data for salinity across the system.
In the peatland ecosystem, it's another wetland ecosystem. When you re-wet it, the emission of methane, shoot up, while CO2 is decreasing. So it's trade-off. More questions? Going, gone. Oh, hey, it's another one. Sorry, Cecilia.
Last bid.
A lot of pressure. Thank you. It's a comment, final comment about it. Like Frida said about how to integrate mangroves in our greenhouse gases inventory. In the case of Costa Rica, it was very similar to Indonesia because our carbon data related with mangroves are in the forest thing, in the inventory. And with support of NOAA in the United States,
with a few sessions, technical sessions, and in fact, Silvestrum was in that project. We can advance in this technical issue. It's very, very technical, but if in the countries have the technical people, it's very easy to understand how to separate the flux and data, carbon data from mangroves into the greenhouse gases inventory, and how to make possible to implement the wetland supplement from the IPCC. This is a learn that Costa Rica have now, and is a recommendation for you, for NGOs and academic people, that is a very good kind of invest to start the technical work related on the wetland supplement and how to separate the specific data related to mangroves in the greenhouse gases inventory. So with this example that probably Steve can add more details, was very technical, but it's not too many complicated issues. So we need to create the specific allies. In the case of United States was NOAA, but I think that in another region there are another expert people, but it's a very good idea. And then if you have this information, specific information in your greenhouse gases inventory, you can advance in the general agenda of blue carbon. And yeah.
Thank you, Costa Rica. That's, Steve, you want to comment?
Yeah, actually, just to build on that, yes, there's a lot of help around if a country wants to include coastal wetlands or mangroves in the forestry or into coastal wetlands. But I think Costa Rica is a fantastic example of what next. You know, we can all geek out on the inclusion of these things in inventories, but Costa Rica took that information and developed a blue carbon action plan and got it into policy. And so I would really say, look at what happened in Costa Rica as to where these things can go next. And I think that's a fantastic example. We were very pleased to help, you know, with a little bit of technical information sharing, but that next step is really why we do it. And so please do look at the experience from Costa Rica there.
Good, thank you. Well, to end, I think in all this reporting system, including in the NDC, there is a chapter called Future Improvement. So please be mindful about that. With that, we would like to finish this session. Thank you very much for your attention. Let's give a round of applause to the speakers.